The sun's light lasts a very long time, but it doesn't last forever. All stars have a limited lifetime, just like all people have a limited lifetime. Our life on this planet is inextricably linked with the sun's life cycle. But how do we know about the sun's life? When it was born and when it will die? The sun was forming within what scientists call a molecular cloud, the dust and gas debris from hundreds of exploding stars, mainly made up of hydrogen, the most common element in the universe. Gravity draws the atoms together so that over the course of 1 million years, the cloud collapses in on itself. Gradually, more and more material clumps together at the center. Molecules rotate more quickly in the middle, which become denser and denser until the atoms in the center become so packed, so compressed, they heat up. The temperature of the cloud soars to millions of degrees, so hot that the hydrogen atoms slam into each other and fuse. Huge explosions of energy are released, pushed outwards against the force of gravity. Throughout its life, the sun was in an endless tug-of-war between these two forces, until there was a stalemate. The pressures balanced each other, and the sun was born. The sun crushed together more than 99% of the original molecular cloud. The little bit that was left then formed the Earth and the other planets in a disk around the sun. Every second the sun shines, it releases the same amount of energy as 1 million H-bombs. The sun's light is made up of particles called photons born in the core, which are then propelled by convection currents through the radiative and convective zones of the sun. Eventually, they reach the volatile outer layers of our star. The photosphere is only around 10,000 or a little more Fahrenheit, and the corona, on the other hand, is millions of degrees hotter. It all starts at the sun's core, where every second, nearly 700 million tons of the universe's most common element, hydrogen, are converted into helium through nuclear fusion, giving off the energy that become photons. Once out of the sun's interior, photons are only 8 minutes away from Earth. But they're leaving behind a world in constant motion. The solar surface boils. The energy rises constantly from below. Coils of plasma and energy called coronal loops spring across the sun, while dark regions known as sunspots stretch thousands of miles, and at only 7,000 degrees Fahrenheit. These sunspots are the coolest part of the sun, emitting less light than the surrounding area, appearing on the surface easy to see. Their genesis, however, is tied to the sun's deep interior and complex rotation. The equator completes one rotation in 25 days. Mid-latitudes complete one rotation in about 30 days. And near the poles, one rotation is completed in about 35 days, called differential rotation. This process makes the sun's interior churn at different speeds, creating intense magnetism in the form of millions of magnetic field lines, which gets mixed up as the sun's interior twists up like a rubber band. This builds pressure, which makes them buoyant, so they float up to the surface, and where they pop through the surface, this creates sunspots. When those sunspots start to twist around, there's a magnetic field that connects two of them, gets twisted, even pops and releases a massive amount of energy. It's these magnetic field lines that are behind most theories on why the corona is so much hotter than the surface. And it's this heat delivered to the corona that radiates out into space, filling our solar system with the sun's energy. But this energy is not constant. Our sun is an ephemeral body, never the same from one day or 1 year to the next. And with a solar season change from solar minimum to solar maximum, anything can change. The transition between solar minimums is called the solar cycle, an average 11-year period in which the sun's activity maxes out then ebbs again. The primary measure of the solar activity cycle is the number of sunspots visible on the sun. When there are many sunspots, there are lots of flares and coronal mass ejections. The sun is turbulent, especially during solar maximum, the peak of solar storm activity. During the solar maximum, the magnetic field of the corona becomes very complicated, and we have a magnetic field everywhere, all around, even near the poles. Solar flares of violent eruptions of energy, usually near sunspots, burst into space like a bolt of lightning, quick and powerful. They can happen over a matter of minutes and can give off the same amount of energy as 1 billion megatons of dynamite. And they can reach us in just 15 minutes. We know how the sun was born, how it nurtures us, and how it has also thrown a fair amount of danger our way. But that's nothing compared to what happens to life on Earth as the sun heats up and dies. Step into the sun's distant future, the hydrogen fuel is slowly running out. But the nuclear reactions at the heart of the sun are not slowing down, they're speeding up. Pressure at the core drops as the fuel is burned. Lower pressure no longer holds the forces of gravity at bay. Now, gravity compresses the core, which heats the hydrogen up even more and makes the fuel burn faster. This increases the pressure coming from the core. The two forces balance again, but it's a cycle that continues as more fuel is burned and the sun gets hotter and hotter. The danger zone will move outwards, scorching the Earth, turning the surface of the planet into a giant series of sand dunes. More and more water will evaporate until all our oceans disappear. And it's this disaster that will make human life on Earth impossible. Right now, we need to be long gone from the neighborhood and move to another planet. Now the sun swells and changes color from yellow to red, becoming what astronomers call a red giant, an old star entering the last stage of its life. It gave us life, and with its death, all life on Earth will be gone. So each time you're lying on the beach enjoying the sun, remember, it won't last forever.